Lovely to see you, lovely to be back in our space. 7C.1, expected number. I think this is probably the easiest exercise in the textbook. So I think our question is, Matt is a goalkeeper and he has a probability of saving a penalty shot of 0.62, and given 37 trials, how many do we expect him to save? Okay, so well, the expected number of saves is equal to the number of trials times the probability of him saving them. All right, so that's going to be 37 times 0.62. Just do that one in my head. 23 saves we expect. Okay, so that is literally all you're doing in 7C.1. Cheese. Okay, on to 7C.2. Now we've looked at probability distributions. Thanks, Brad. Just chuck it on the desk back there. And we've looked at finding the mode and the median. Today we're going to look at how we find the mean for a probability distribution. So the difference between here and here is that here we have a distribution. Here we're just talking about the probability of one event occurring. Okay, so now we've got the distribution. We're going to show you how we find the mean. Now the formula I've got written there is sum of xi pi. Alright, so I'll explain what that means. First, let's solve for k, because we know that the sum of all probabilities equals 1. So 0.4 plus 0.3 plus 2k plus k equals 1. Here we're going to get 3k is 0.3 and k is 0.1. Alright, at the sum of all those probabilities, here we'll have 0.7, we'll take it. K is 0.1. So what that means our table becomes is this. Alright, and so we've filled in the probabilities, and now we're ready to calculate the mean. Okay, so this is how we calculate the mean. It is, what does this symbol mean? It means the sum of each event times the probability of that event occurring. Okay? So for our mean, we can use mean, we can use E of x. Okay, there's a couple of ways that we can represent it. The mean is the expected value that the random variable capital X will take. We use capital X to say our random variable. Lowercase x describes the events that can occur. Alright, and so it's going to be equal to 0 times 0.4. Okay, 0 times 0.4 plus the next event times each respective probability. 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. Calculate this out. 0.3 plus 0.4 plus 0.3 equals 1. Okay, so the mean here is 1, and that's just a coincidence. It will not always be 1, alright? It's just that we followed the process, performed the formula for the mean, and we found that the expected value, the mean of this distribution is 1. Okay? So that's it, the sum of each value times its respective probability. Now, I will show you a bit later on how we can use our calculator to perform this, but to start with, we will do it manually. Okay, next, we're asked to find the mode and the median. Okay, well remember, the mode is the event that has the highest probability. So we look along here, what's the highest probability? 0.4 is the highest probability. What's the event that corresponds to 0.4? It is 0. So our mode is 0. And our median is when the cumulative probability reaches / exceeds 0.5. So if we look here, the probability is 0.4. And so then when we move on to the next event, we have 0.4 plus 0.3, we get to 0.7. And that is where it exceeds 0.5. So that is where the median occurs at x is 1. So for this distribution, we have a mode of 0, a median of 1, and a mean also of 1. So that's enough to get through 7C.1, 7C.2. I probably don't want to go move any further along than that, so let's make our way through those. Bit of 7B today, 7C.1, 7C.2. Cool. Excellent.